Welcome back to part 4 of our GitHub Bootcamp. We're talking about actions and workflows today, getting on to the CD part of CI/CD. And with that, I'll turn it over to Dave Burnison from GitHub to kick us off.
Awesome. Thank you, Matthew. Good morning, good afternoon, good evening, depending on where and when you are watching this today. My name is Dave Burnison. I'm a technical advocate from GitHub. Thank you for joining us for our first 3 sessions, and welcome back to our GitHub Bootcamp on YouTube Live and Twitch. Now, Microsoft's mission statement is to empower every person and every organization on the planet to achieve more. And GitHub's vision is to be the home for all developers. And we're bringing these together to say that GitHub will become your home for DevOps tools, empowering more than 73 million users to achieve more for their organizations. So we've got 6 sessions in total, and some of these sessions are for everyone and some are for more technical people. Now, today's session, similar to this past Tuesday's session, is a bit more technical than our first 2 sessions. So in today's session, we're going to cover several important topics. We'll start with GitHub Actions, workflows, and the events that trigger workflows. We'll talk about runners. This is where your actions actually get executed. Then we'll talk about continuous integration process, including the related automated tests, and also the continuous delivery process, including automated tests. And of course, we'll answer your questions as we go, and we hope to have time to answer more questions at the end. Behind the scene, myself and other subject matter experts from GitHub will be answering the questions that typed in by our audience. We've got another outstanding collection of presenters today, and these are Nithya, Harleen, Deep, and Besti. Take it away, Nithya.
Thanks, Dave. Thanks for the quick introduction. So let me go ahead and share my screen. Okay. On to the quick recap on what we saw in the previous session, right? We learned more about what GitHub repos is all about, how to integrate GitHub apps with your repository and take advantage of it, right? And we saw more about branch protection policy and how code spaces can be used to enhance developer productivity and velocity. We also saw how to raise a pull request and how it goes through the approval phase and get the code merged into a master. But in today's session, we will see more about CD, as Dave said, continuous delivery, how to perform the automated test, learn more about actions, workflows, and even more details about what runners is all about. So this is all for today. And before we get started into the technical concept, I wanted to show certain current KPI metrics of one of our application called bookings. And let's quickly navigate to the Grafana dashboard and see how the deployment frequency looks like. So let me just go onto my browser, and we have a centralized dashboard where we see all the DORA metrics. And I wanted to double click on one of the KPI metrics, which is very less. And just in the interest of time, I'll navigate here. And I average deployment frequency is somewhere around 5 across all the environment, which is very less. So we wanted to increase this deployment frequency and be a bit more elite or high performance team, and make sure the metrics are very good. And that's our main focus today. And we would be looking into how to increase this KPI metrics and get the data all that we wanted. Correct. So why are we measuring it in the first place? So measuring deployment frequency offers an opportunity to understand how well our organization and the process functions. Now, as per the DORA research, the latest finding reveals that high performer will make multiple deployments per day, while low performing teams or DevOps team will deploy somewhere between once per month to once per 6 months. So our KPI on the deployment frequency is much, much lesser. So we wanted to enhance it. So we will see how effectively we increase this KPI metric post adopting to the concepts that we are going to learn, how to implement automated testing, how to implement CI, CD with testing, and let's see post this session and how the KPI metrics has increased, right? So a quick introduction. We have our fantastic team here today for today's session, who will also be playing key roles of an engineering team. So I'll be acting as architect, and Bestie as infra engineer, and Harleen and Deep would be the feature team engineers who will be working on CI and CD test cases. Right, a quick simulation for since we are looking to enhance CI/CD capabilities and practices, we would like to explore more on the following topics. So I will be explaining how actions work, what is all event is about, how to trigger an event, and what is workflow files and how it is constructed.
As an infra engineer, my role is to make life easier for our feature teams. So I'm going to take a look at the runners.
And I'll utilize the concepts taught by Nithya and shown by Beste about the actions, events, workflows to show you how you can use these concepts to create CI workflows.
And then I will be integrating continuous deployment for the smart hotel application with various type of tests.
Great. And we'll also see on the KPI dashboard again and see how the metrics has increased post adopting to these set of features. With that, we'll get into the technical concept. Since we need to implement CI/CD along with the testing, so I've done some research on how GitHub features covering actions, events, and workflow would look like, and I wanted to explain this to our feature team. So GitHub Actions helps us to automate tasks within our HDL process or software development lifecycle. GitHub Actions are event driven, meaning we can run a series of command after specified event has occurred. For example, every time someone creates a pull request for a repository, we can automatically run a command that executes a script or an intended action. So GitHub Actions are a way of automating your workflow in simple. So they are triggered on any event on GitHub. So to put it simpler, GitHub Actions has three parts. One is events, workflows, and actions. So let's double click on each and every concept and learn more about it. An event is a specific activity in a repository that triggers a workflow run. For example, an activity can originate from GitHub when someone creates a pull request or opens an issue or even pushes a commit to a repository. An event automatically triggers the workflow file, so which contains a job, and the job then uses steps to control in order in which the actions to run. So these actions are commands that automate your software testing. It can be as simple as running a partial script, as simple as running a bash script, or you wanted to perform certain action of deploying a template to a target cloud environment. It can be anything. So you can use those actions within your workflow file and get that triggered by using events. So there are a list of multiple GitHub action components that work together to run the job. So you can see that in the screen. So you have an event has a job, it can also have multiple jobs, and these jobs can also be dependent on each other, and it has multiple steps underneath, and steps performs these various actions that you incorporate within your workflow file. And not only that, these actions can also log what is the result, and you can consume those artifacts in your consequent workflow. We will learn more about that in the next slide. More about events. How do I define this event in my workflow file, right? There are various ways you can define these events. Either it can be of a single event, you just want your workflow file to listen when there is a push activity, or you say there is a pull activity, you can do that. Or you want a list of events that needs to be present on your workflow file. Say for example, if someone pulls, you want your workflow to be triggered, you can do so. Or it can also be manual events. I don't want my workflow file to be triggered on an external event, rather I need to manually run it. You can also do so by specifying the workflow dispatch as the event. Or you want your workflow file to listen to external calls like webhook and everything, and you want your workflow to file to run, you can also do so. So there are various ways to schedule the events, and even there is also possibility to schedule your event by using certain syntax or our own cron syntax, by specifying which date, time, month, or second that your workflow file has to be triggered. You can also do so. So this is how you incorporate events into your workflow file. Correct? Now, what exactly workflow files are about? Now, we learned about events, but workflow file is an automated procedure that you add to your repository. Workflows are made up of one or more jobs and can be scheduled or triggered by an event. The workflow can be used to build, test, package or release or deploy an application to the target environment, or it can be cloud platform, or it can be your on premises, anywhere, right? Workflows are what end user consumes. These are your pipelines. If you're coming from Azure DevOps world or Jenkins worlds, it's a plain a pipeline which you give it to your orchestrator to perform certain actions, right? These workflows, some similarities, it's also in YAML syntax. You need to have proper properties specified, and in GitHub you store these workflow file, or all workflow files are stored under the directory .github/workflows, right? More about workflows, how workflows work, right? It listens to a particular event, runs the pre-existing action, and sorry, and logs the results and artifact to a specified location. So as we discussed, a workflow file is constructed in such a way that it listens to an event. We learned what event is all about. It can either be push or pull or multi webhook or manual or kind of a thing. It runs the set of code on a runner. We will learn more about runners in the upcoming slides. And it runs the pre-existing action. These action can be specified by you, or the pre-created actions which is readily available in the GitHub marketplace. Or you can also create your own GitHub actions and publish it and consume that in your workflow files. So everything is possible. So these, so where do you run these actions on? So if you are coming from an Azure DevOps world, you specify a runner, right? Or which platform or which operating system my piece of code has to run on. Either it can be Windows, Linux, Mac OS. Same way, GitHub workflow can also, you can also specify run as virtual machine. Either you can use your own, or you can use GitHub runners, which we'll learn more about in the upcoming slide. And it supports Windows, Mac, and Linux, or even you can use your own containers too. And workflow also has a capability to store the logs and artifacts. So artifacts allow you to persist data after a job has completed and share the data with another job in same workflow. An artifact is a file or a collection of file produced during a workflow run. So all collections and workflow runs called within a run has the right access to that runner artifact. So by default, GitHub stores this build logs and artifacts for 90 days, but this retention period can be customized based on the developer's need. Now we learned about events. We know what workflow file is constructed of. What are actions? So actions are the actual reusable unit of code that is made available to your workflow. Now people coming from Azure DevOps, how to pipeline, actions are simply put are the tasks that you execute in your pipeline. It can be, as I said, as simple as running a script. It can be installing a package by installing npm or calling a node package manager, or it can also be deploying your infrastructure templates to a target cloud platform. So all these actions which perform intended action that you integrate within your workflow file to perform the required action. So actions are the smallest portable building blocks of your workflow, which can create, as I said, we can create your own actions too, or you can use community driven or marketplace available actions and integrate that into your workflow file. Just to give some example, if you want to publish a package to an npm, or the most common is that you want to do a complete CI/CD setup, or I would just speak from an infrastructure and you wanted to completely automate your infrastructure deployment using ARM templates, Terraform templates, and you want an automated procedure. You have stored all the templates in the source control manager, and you want to automate the deployment to the Azure in an automated flow. Then you can use pre-existing actions released from Azure and consume that into your workflow file and create a workflow to do those actions. So that's what actions are all about. Where do I find these actions? As I said, if you want to quickly reuse certain actions, you can navigate to GitHub Marketplace and search for certain actions which can be readily consumed, and you can input all the required parameters and perform the action. But as a security measure, administrator has the control over what actions that you will be allowed to run. So either you can allow all actions on your repository, or if you want, due to security concern, I want completely disabled all my actions on my repository, you can do so, or allow only local actions to be run, or allow select actions to run on a repository. So all those control are with the admin of the organization, who controls what type of actions to be allowed or not allowed. A quick comparison between Azure pipelines versus GitHub Actions. There are a lot of similarities that you see on the screen. Workflow configuration files are written in YAML. Both Azure pipelines are also written in YAML, and GitHub actions or workflows are also written in YAML. Workflow includes one or more jobs. Same here. GitHub pipelines or Azure pipelines also has one or more jobs, and job include one or more steps on an individual command. Similar way, GitHub actions also has one or more steps. Underneath it has an action, but in the Azure pipeline world or DevOps world, you would specify it as task and call the specific task. In the GitHub workflow world, you will use an action and specify those properties. A quick comparison between how the Azure pipeline versus GitHub actions look like. With that of much of theory, let's quickly jump into the action and actually see how the workflow files are and what are the actions made up of. So let me go back to my repository. So I have a GitHub org called Microsoft DevOps Dojo. Underneath, I have multiple repositories. So I have an infrastructure repository which I've created. And as we learned, all the workflow files are stored under .github workflow folder. I have multiple workflow files here. I'll just open as simple a workflow file called simple manual workflow file with multiple jobs. What it has a workflow file which listens on a event. This is workflow dispatch in the sense it doesn't listen to an external trigger, rather you run it manually. And you have your runner specified on which it has to run, and then you have multiple jobs. So I have job as dev, and another job as test, another job as prod. And let's see how you can run this workflow. So I go back to my actions and I click on multiple jobs. Since it is a manual workflow, I click on run workflow, specify certain properties, and click on run. So what it actually does is that since I have the event which I configured as workflow dispatch, it waits for me to run the workflow manually, and it runs the and starts the job and make sure that all the steps and actions that are specified in the workflow are executed. In the interest of time, I just wanted to navigate to the workflow which I've recently done. You see, the jobs are visible in such a way that my job test has executed, my job prod has executed, it was dependent on both, and job dev is also executed, and all the underneath steps and actions are also executed. If I double click on the test, you would see all the task or actions that has been accomplished. Okay, now that we have seen what GitHub actions, workflows, and events are, now let's learn more about GitHub runners. So Bestie, over to you.
Thank you, Nitya. So we have been talking about actions and workflows. These all need a place to run on, and it's called a runner in GitHub. So a runner is nothing more than a server that has the GitHub Actions runner application installed on it. And it's the same as the agents in Azure DevOps. So this application, GitHub Actions runner, it listens for available jobs, runs one job at a time, reports progress and logs and the results to GitHub back again. You can use a runner hosted by GitHub, or you can host your own. So let's take a look at the ones hosted by GitHub. So as the name suggests, these are managed and maintained by GitHub. There are 3 flavors of operating systems available. GitHub hosts Linux and Windows runners on virtual machines on Azure, and the Mac OS runners in GitHub's own Mac OS clouds. So these machines receive automatic updates for the operating system, for the pre-installed packages, tools, and the updates on the runner application. And they provide a clean instance for every job execution. Each step in a job executes on the same runner, allowing actions to share data with each other. But for every job execution, there's a new one created. So if you want to use this, you can use the free minutes on your GitHub plan, or you can pay per minute for usage. And there are also self-hosted runners. Self-hosted runner is a server hosted by the user in the cloud or on-premise. The only thing needed is this GitHub Actions runner application needs to be installed on it. And through this application, the self-hosted runner polls GitHub to retrieve application updates and to check if any jobs are queued for processing. So self-hosted runners offer more control of hardware, operating system, and software tools. They can be physical servers, virtual machines, or they can also just be containers. they receive automatic updates from GitHub just for this GitHub Actions runner application. And the user is responsible for the rest. And it's also possible to configure access management on these runners to decide who is allowed to use them. But this extra control, it comes with a price tag, that being the management, maintenance, and of course, the costs of these machines. So, and if the GitHub runner application on a runner machine doesn't connect GitHub for 30 days, then it's removed from GitHub. Important thing, GitHub recommends against using self-hosted runners for public repos. But why? So imagine this, a self-hosted runner on premises behind a firewall, and the IP is hidden. It's unsecure, but the repository is public. So someone may fork the repo and then run unintended jobs on our runners. And then they can run malicious programs or escape the machine's runner sandbox. Shortly, they can cause damage. What we can do to minimize the risk is to leverage the IP allow list for self-hosted runner security, but still, it's highly recommended to use self-hosted runners only with private repositories. So as I mentioned before, it is possible to configure access on the self-hosted runners, and the best way to do it to use the runner groups. These are just like the agent pools in Azure DevOps. So the enterprise admins, they can configure access policies that control which organizations in an enterprise have access to the runner group. One level deeper, the organization admins can configure access policies that control which repositories in the organization have access to the runner group. And it's possible to move runners from one group to another. So let me show you where we can find these runners on GitHub. So going back to our repository, this is my repo. And as Nitya mentioned, all the workflows are stored under the GitHub folder, GitHub workflows, and just open the first one. So if you look at this, here we have this runs on statement. So this one is using an Ubuntu image. So this is a GitHub hosted runner. If we would like to create our own runners, what we could do, the self-hosted ones, we would go to the settings, and then here under the actions, choose runners, new self-hosted runner. And then I can choose the operating system flavor, and then doing this configuration on this machine or my container, and then that would create the self-hosted runner. And then I would use this in my YAML pipelines to say, go and run this on my self-hosted runner. So looking at this and comparing the GitHub hosted and self-hosted runners, I think for our project, the best way to go is to leave this to GitHub. So Harleen, please go on and configure your continuous integration flows on a GitHub hosted runner.
Sure. Thanks, Beste and Nitya, for introducing the actions, events, workflows, and runners. So during the next part of this session, we will see how we can leverage all these concepts in the CI process.
Harleen, in the previous session, we looked at the elements of continuous integration, but could you please go a little bit deeper to give me understanding of this continuous integration, what it is?
Sure, Vesti. I think that's a good point to start. So let me get started with continuous integration. So I'll start with the definition from Martin Fowler. So continuous integration is a software development practice where members of a team, they integrate their work frequently. And by frequently, we mean that every person within the team integrates at least once daily. So within a feature team, there are multiple integrations per day. By leveraging continuous integrations, we are ensuring that we are maintaining the quality standards because the tests are executed at various levels and the results are transparently available to the entire team. The goal of this approach is that we should have a faster feedback during the development. Now, this approach, it brings along with it multifold benefits. So let's look at some of them. First and foremost, this approach helps us to ensure that the code is always in a deployable state, thanks to all the testing that we can do. Then the focus is on the working of the integrated code rather than just working on one piece of code which is focusing only on a particular feature. Okay, so you're ensuring that everything can be stitched together and is working as a whole. With CI, we are able to get fast automated feedback on production readiness, and we know if the releases they can happen in a sustainable manner. It also means that the deployment, it becomes a business decision rather than a technical one. So the moment business owner says that, okay, I want this feature to be delivered, we are ready to deliver it. So Beste, I hope this helps you understand like what CI is and what are the various benefits.
Definitely. Thank you.
Okay, so I'll move to CI/CD workflow. Now, when we talk about CI/CD workflow, we have to think how we can create this. First thing is that we have to utilize the GitHub Actions. GitHub Actions, like Nitya mentioned, they offer workflows that can build the code in your repository. You can write steps to execute certain tests on your code, and these workflows they can run on GitHub hosted runners or self-hosted runners. So now let me show you a quick demo of how you can create a simple CI workflow. So I'll go to my GitHub organization here. So currently I'm having 3 repos within my organization. So I'll be using the bookings repo. Now within the bookings repo, remember that we have to utilize the actions. So let's go to the actions tab here. Now, when we go to actions, there is an option to create a new workflow. Okay, so when I select this new workflow, you see GitHub is smart enough to understand what kind of code I have in my repository. Now it says that, okay, since I have the .NET code in my repository, it is suggesting me the actions accordingly. Now I do not have to forcibly use what is available in the marketplace. I have the flexibility of creating my own workflow. So I can go ahead, say, okay, set up a workflow yourself. And this is where it provides me with a skeleton of the workflow, starting with the name of the workflow file, what is going to trigger this workflow, a push event on the main branch, a pull request on the main branch, or if I want to trigger this workflow manually, I can include this workflow dispatch. Now, every workflow, it can have one or more jobs. So this is where the job part starts. And the first job, this workflow is currently having only one job, and it is with the name build. Okay. And then comes where this job has to run. Now, this will be utilizing the runners. Now, my runner, will it be Ubuntu? Will it be like something which you will be using Ubuntu, or will it be a Windows based or a Mac OS based? This is where we can specify that. Then what will be the steps that will be part of this job? So I can define all these steps here. Things like checking out the code from the repository, then maybe setting up the environment, then trying to build the source code. Now, there may be times when you would want to include certain steps in your workflow and you may not know the syntax for it, right? This is where things in the marketplace comes really handy. So suppose for this workflow, you want to include steps to upload a build artifact, okay? Or say download a build artifact, anything like that. So let's take an example of downloading the build artifact. Okay, so all I have to do is I can open this action in the marketplace, and I can see what all what is the syntax for this action, and I can simply copy this syntax and utilize it in my workflow. As simple as that. And once you're done, all you have to do is you can go ahead and create a new branch as a best practice. Don't ever commit to the main branch. So I'll go ahead, create a branch, and say, okay, this is a CI workflow, and propose new file. Okay, so that's how easily you can create a new workflow. Now, you may ask me that, is that it, what you can do in the CI workflow? Well, there is more to it, and let me show you what it can be. Consider a scenario wherein for your application, you want to build the source code of the application with different versions of .NET, or you want to test your applications on different operating systems, right? Will you be writing a different workflow file for each version? No, right? That sounds a lot of work. So a solution for that is to use the build metrics. Now, a build metrics is a set of keys and values that allows you to spawn several jobs from a single job definition. Now, this, if you see on screen, this CI workflow, it will be using every key value combination that is specified in the build metrics to run this particular job. So this allows you to run the job to test your code on different versions of any language, or different versions of, by using different versions of a library or an operating system. So for this workflow example here, you see this this job, it will be running on different versions of different operating systems, and it will be built using different versions of Node. So making life easy, right? And then in addition to this, you can also include several tests in your CI workflow. So let me show you what all tests can be included. Now, you can include your build verification tests, you can include unit tests. There can be several tests included from security standpoint, but I'll not deep dive into that part because we have our next session, session 5, which is dedicated especially on the security. So for the scope of this session, I'll just focus on build verification and the unit test part. Now, having understood this, let me quickly show you how these build verification tests and the unit tests can be included in the CI workflow. So for this, I'll show you an example of the Smart Hotel 360, the CI workflow for that. So let me bring up the browser here. So again, we are back to our GitHub organization. So we'll be looking at the bookings repo here. Now, within the bookings repo, remember Nitya told that all the workflows, they are located under .github folder. So if you go to .github folder, you have this workflows folder here. And within this workflow folder, you have booking CI base. Now, let's look at what this booking CI base files looks like. So starting with name, what triggers this workflow, and then moving ahead, we have the build job. Now this build job has several steps like checking out the code from the repository, setting up your environment variables, and then setting up NuGet. It will be trying to restore a certain NuGet packages and then update the NuGet to the latest, right? And then post that, you can build your solution. Okay, so build your source, everything is okay, and then you can go ahead and run some tests on that code. these are the steps where we have specified I want to run once the successful. Now, once then I went ahead and upload the artifacts that are generated to certain I specify where the artifacts are uploaded. I can publish those artifacts. These published artifacts, they will be used by the CD workflow. And if you see here, we are calling the CD workflow here, and we'll deep dive into. This is the structure that we have for our CI workflow. Now, let's look at how we can trigger the CI workflow. So I'll go to the actions here, and within this,
Hey, Harleen.
I have bookings CI base. Yes. Hi.
Doing great. Could you just zoom in on your browser just a little bit so we can see the text a little better?
Okay, sure. Let's do that. Does it look better?
Great. Cool. Thank you so much. Sorry to interrupt.
Okay. Okay. So we are on the booking CI base. Here. So all I can do is go here and say, I will to run. Oh, let's see what is happening here.
Hey, Harleen.
Now
we've got a.
You come here and say branch or any different that you might have.
Okay, Harleen was having just a little bit of network issues, so we'll just give her a minute. She'll be right back. We're in the middle of the CI part. This usually resolves itself pretty quickly. So.
I think she was almost done. Maybe we can go to Deep.
Sure.
Yep.
Do you want to take over, Deep?
Yeah.
Sure thing.
Okay. Let me know when you're ready.
I am. So yeah, thank you. Thank you for setting up the CI, Harleen. Now let's see how we can go ahead with the continuous deployment for the smart hotel application and how we can integrate various type of tests for that. First, let's look into what is continuous delivery. Now, with continuous delivery, we have a latest code could continuously added into a main branch, and with and if you see continuous deployment, we go an extra step and we go ahead to deploy that code of our main branch into our production environment basically. Now we have various forms of continuous deployment, starting from infrastructure deployment, application deployment, API deployment, and we have package deployment as well. Now, infrastructure deployment, we mainly have two types of two types of template that we utilize for infrastructure deployment. These are ARM templates and these are Terraform templates. Let's see how do we utilize these templates to deploy the infrastructure of our smart hotel application. So if I just head over to my browser, Here you find we have a folder called Terraform templates, where we have stored the template of of deployment for our deployment for a resource group. So if you see this, this file is a Terraform template which is responsible for deployment of a resource group. Then let's look at where do we have our ARM templates. So if you see, we have a folder here called ARM templates, and over here you will find all the ARM templates which are responsible for deployment of our cloud resources onto Azure. Now let's see how do we utilize these these template files in our workflows. So if you see over here, we do have a workflow as uh, Terraform apply, and this is basically responsible for deployment of the Terraform templates that we just saw. So if you see over here, we have this action of HashiCorp, which is available out of the box in the GitHub marketplace that we initially have, and then we have these three steps of initialize, validate, and apply, which in turn utilizes these template files that we just saw. Now let's see let's see how do we utilize the ARM templates for deployment of our resources onto the cloud. So if you see over here, we have a workflow over here, and in the start over here, we have an action called uh, called login into Azure, and this in turn utilizes these secrets which we uh, have in our uh, GitHub secrets, and then we have these actions available in the GitHub marketplace, and these actions are responsible for utilizing the ARM templates. So if you see, this action is either you can utilize this action or you can utilize AZCLI for deployment of your templates. If you have your template file, if you specify the parameters, and then after this it will then let's see, like we have already ran this workflow. Let's see its output. So if you see over here, as I specified, we initially have a job of login into Azure, and then we have these jobs which are responsible for deployment of resources in our cloud. And this is how our resources look like basically after we haven't been, been have deployed them. Now let's see what are uh, let's see what are environments. So environments are basically uh, these are these are basically logical representations of the environments that have to we have to deploy our resources onto. Now we can have environments like dev, QA, prod, and each of these environments, sorry for that, and 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 each of these environments, excuse me, sorry for that, and 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 each of these environments have their own secrets, and they have their own protection rules that we can utilize and have workflows. Let's look at what are protection rules. So have a set we can have a of set of protection rules for our environments, in which we can have up to 6 required reviewers. Then uh, then we can then we can also set a wait timer, and we do have some and we do have some APIs for third party integrations as well. Just a minute. Now let's see what are deployment logs. So have a we have we have these deployment logs, which uh, which help us to see like all the deployments been that have been that have been made in in environment by whom and when. So if you see over here in the browser, if I go to my repository, here you'll find on the right hand side something called as environments. And if I see here, I will see the environment it was deployed to, by whom and when. So we basically have this option of seeing all our logs of deployment, and then and seeing if you like have to see the detailed deployment logs, you can just click over here and see all the logs and all the details of that particular deployment. Okay, now we have various type of tests that we can also integrate with our continuous seed with our continuous deployment process. These tests include UI testing, BDD testing, API testing, accessibility, infrastructure, and we also have web security testing as well. And in the end, let's see like how we have implemented this for the smart hotel application, and how we have actually used th- this for an, an in an end-to-end implementation. So if you see over here, this is our deployment. This is our deployment strategy. So if you see over here, as soon as our CI workflow succeeds, we now have an artifact ready to be used by our CD workflow. And now over here, this is our main workflow, which in turn calls our which in turn calls the reusable workflow thrice in dev, QA, and the production environment. Now, the now we have this reusable workflow, which in turn calls 6 individual uh, composite actions to have their each individual task. So with these actions, we actually reduce duplicity and increase reusability, since these actions can be actually utilized like across our repositories and across our workflows as well. Let's see how we have implemented this entire flow. So if I just head over to here, starting with, we have all these variable groups for each of the different environments that we have, say dev, QA, and prod. For each environments, we have these all these value and its pairs. These and we utilize these variables in our CD workflow. Now let's see how the 3D work how our 3D CD workflow looks like. So if you see over here, we initially have a trigger called as workflow run. This means that as soon as the 3i is successful, uh this thi- this workflow will be initiated uh, automatically. And then if you see over here, we have with we have it with 3 different jobs, that is released to dev, released to QA, and released to prod. Now each of this job turn in turn utilizes in turn utilizes this reusable workflow, and the only difference is that we have this input value that changes of environment. So if you see this this initially released to dev has this environment value called dev sent over there. Then we have QA and prod. And and also if you notice, we have the release to QA, is actually which is actually dependent on the release to dev. So meaning only after the release to dev is successful, we have the release to QA, and then we have the release to prod. Now let's see have how we have utilized our reusable workflow. So if you see over here, we have a we have but trigger called has workflow call. This has all these inputs that it utilizes to run the workflow. This flow has six. This flow has 6 different jobs for like releasing to releasing to cloud. Then we have the BDD test, UI test, and all of these jobs. These jobs in turn utilizes the composite actions that I just showed you. So if you see for example over here, we have a job for BDD test. Over here, if you see, we have this action that is located over here, that is dot GitHub slash actions. And over here, we actually set in send in some input values. Then let's see how these actions are like look like. So if you see over here, we have a folder called dot GitHub slash actions, and inside of this we have these individual actions. And each action, if you see inside of it, you will find a single file called action.yaml. Each of these YAML files has the responsible jobs to perform. So if you see in the start, you will find these input values that it takes, and then over here we have all these actions that is supposed to run. And in the end, if you see, we have this action of actually running the BDD test. N- 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 Let's see how does this look like in an end-to-end flow. So if you see, we have this as released to dev. This uh, entire thing is a single entire thing is a uh, single reusable workflow, and this each of these actions are each individual composite actions. Then as soon as we have the dev has succeeded, we go to QA, which is again the same reusable workflow. And then as soon as we have the QA done, we go to prod. Now let's see how we can see the l- results of all our tests. So if you see over here, we say we have this test called UI test, and if I just go over here and if I see all the logs, here in the end I will find the results saying the total number of tests passed, the total number of tests skipped and failed. So here we are looking at a summary of of all our tests. So this is how you can actually see all the results. Now say say that uh, say that any of our say that any of our tests fail. So we have to have a way to uh to actually see all the results of the failed test, right? So for for this reason, we have added another job called issues creation, which in turn is responsible for automatically creating a GitHub issue whenever a whenever a test fails. Then we have also integrated another flow to actually sync all this GitHub issues with our ADO bugs, since we are still utilizing ADO for project management. So, so let me show you how does this actually look like. So if you see over here, say if we have these tests which have failed. So if you see, this job has automatically run, and this job is responsible for automatically uh, like automatically creating a GitHub issue. Then this issue, if you look like, it says that that we do have a failure of a test on so and so date. And if you see over here, it has automatically linked this issue with an ADO bug, which looks something like this. So if you see, this bug has also been generated automatically, and if you see on the right hand side, has it has linked this bug to a GitHub issue. So yeah, so since we have now the CI and the CD in place, let's see how our KPIs have improved.
Great. Thank you, Deep. Let me go ahead and share my screen now and see how the KPIs has increased. So I'm back to my Grafana dashboard where I have integrated all my repositories. So since we have been doing this activity past 30 days, and our KPI was the deployment frequency was very less. Our main focus was to imbibe all the GitHub features that Deep showed, Harleen showed, and make use of actions, workers, and what type of runners. Let's navigate to my dashboard, and I see last 30 days report and see how it has improved. So give me a second, let it refresh. Oh, that's great. So let's double click on it and see what are the deployment frequencies per repository on each and every environment that Deep showed, right? So on dev, on QA, and on prod. So let me quickly change the date. Okay, that's great. So we have an average deployment of 5 deployments per day, and the total deployments across dev, QA, and prod is somewhere around 140 to 150, which is a great sign. And thank you all team for the great efforts. So the KPI looks very great. So with that, Dave, over to you for closing thoughts. You're on mute, Dave.
Thank you very much, sir. Yeah, we had a number of questions in chat that I want to address, but also, just want to say great job to Bestie, Nithya, Harleen, and Deep. Great session today. Lots of great information here. Now, if I cut over to my browser window here, if I can get the right browser window on the screen. There we go. Yeah, we had some issues pasting links into the channel today, but I want to point out a couple of things here. If you go to docs.github.com, there's an entire section on GitHub Actions. And I'll point out a couple of things there real quick. When we talk about the events that trigger workflows, there's over 24 different events, and even more specifically, you can dial into specific event types and things. So yes, GitHub Actions is awesome for CI/CD, but you can also trigger workflows when somebody creates an issue or edits an issue in GitHub, or the first time they fork a repo or answer a question in a discussion. So you can use GitHub Actions for so much more than just CI/CD. And then there were some questions on the hosted runners. If we go into hosted runners here, we let's see, was this the one I wanted? There we go, about self-hosted runners. Yes, you can learn more about self-hosted runners and see exactly what compute we have out there for the hosted runners and everything. Now, here I have the another thing I wanted to point out was we're providing more options for self-hosted runners. If I go to the GitHub roadmap, which Matthew put the link in there for us, and I filter this to actions, one of the things we have here is we're adding more powerful choices for GitHub hosted runners. So you'll see once this becomes live, you'll have some choices on exactly what type of compute you want to leverage in your runners and everything. So just wanted to point that out real quickly. All right, back to our slides. Do we have any final questions or anything?
Yeah, there's one from chat, Dave. Can we not put both CI and CD workflow in one YAML file?
Oh, yes. Yes, we absolutely can. All right, let me go back here to the example that I often show customers is, if anybody's read the Phoenix project, I'm sure you're familiar with Parts Unlimited. So we've evolved Parts Unlimited to be a more high-performing DevOps company. So yes, I have an example here where I've got CI in one stage. So that's the build, the unit test. I'm verifying my Azure Resource Manager ARM templates. Then I've got a deployment to dev, QA. We're also leveraging the manual approvals that you can put on your environments in GitHub Actions as well. So now I can go out here, look at my QA environment and see it. In this case, we're Contoso. We bought Parts Unlimited, or I'm sorry, yes, we're Contoso. We are Fabricam. We bought Parts Unlimited from Contoso. So yeah, going back to my production environment, we can see that still says Contoso. So now that we know we've got it all good here in production, then I can go back and say, hey, we can deploy to production because QA looks good to me. Let's ship it, hit the big green approve button, and we're off and running. So Yep, there's an example. Now there's also examples here of, I've got an example here of a workflow where I am, the trigger is on issues. So whenever an issue is created or edited or anything like that, this workflow runs. Now what this workflow does is it's taking the issues that show up here, and it's real easy these days to convert a code QL security vulnerability into an issue. And then the way I have things set up here, I'm integrated with Azure boards, and now those security issues are showing up on my boards combined with my work. So that's just, so here's that security issue. You know, we probably want to say, you know what, we want to reprioritize that work and fix that security issue before we finish off that rebranding work for Fabricam and everything. So, you know, examples of using the multi-stage workflows, using workflows for more than just CI/CD and everything there. All right, so let's wrap things up here. We're a little over past our hour, but again, thank you to Nithya, Harleen, Deep, Bestie, great presentations. We look forward to seeing you in session number 5. Actually, oh, let me check the chat. I saw a question. Public repo, what permission role are needed to kick off a manual action? I'm not sure off the top of my head if one of our other subject matter experts can address that. Actually, bear with me for 1 second here. Let me go back here and pull up my repo. If we go into
If we can
settings,
take that, by default, actions are allowed on the public repos. So
say that again. Nithya?
no, by default, the actions are allowed on the repository. So you have the control to restrict it, but there's no specific permission that is required. As long as you are an admin or of the repository, you'll be able to run the actions. Yep.
Okay, very good. Thank you. Thank you. All right. So there we go. I don't see any other questions. So we'll go ahead and wrap things up. Again, we look forward to seeing you in session number 5. The content in session number 5 will also be more technical than the first 2. You know, we've got several important topics we'll be talking about there, including leveraging GitHub Advanced Security to keep security vulnerabilities out of the code that you write, and also to keep logins, passwords, personal access tokens, and other secrets out of the files stored in your repos. And we'll talk about how to manage those secrets since we don't want them hard-coded in the files that you keep in your repos. And then we'll discuss authentication and authorization. And we'll talk about leveraging branch protections as part of your security plans. And of course, we'll have our subject matter experts available to answer your questions. But you don't have to wait until our next session to learn more or get started with GitHub. Reach out to us at msusdev@microsoft.com and learn more about DevOps Dojo at aka.ms/dojo-intro, or even start a free trial today at github.com/organization/enterprise_plan. But I do have one other thing where you can dive in today, and that is with GitHub Learning Labs. If you go to lab.github.com and search for GitHub Actions, there's a couple of different labs out there where you can go walk through a lot of these scenarios and get hands-on experience. There's the DevOps with GitHub Actions from the GitHub team, and MSUS has even created a common continuous integration team scenarios lab to run through here. So with that, I want to say thank you everybody for attending today, and we look forward to seeing you again next Tuesday for session number 5.
Thank you all.
Thank you all.